Hi everyone, my name is Renjie Zhao, a PhD student of UC San Diego. Today, I'm going to introduce our work, MCube. It is the first mmWave massive MIMO software radio. mmWave technologies represents a cornerstone for emerging wireless network infrastructure and for RF sensing systems in security, health, and automotive domains. Through a MIMO array of phase arrays with hundreds of antenna elements, mmWave can boost wireless bit rates to more than 100 Gbps as proposed in the mmWave Wi-Fi standard 802.11ay, and can potentially achieve near-vision sensing resolution. To conduct research on mmWave massive MIMO, we believe a programmable experimental platform with the following critical capabilities is needed. First, it should be equipped with low-cost and large phase arrays, which represent the key features of mmWave radios. Second, it should support the mmWave MIMO architectures, which is to be used in 5G NR and 802.11ay. Third, fast beam swapping should be available, which allows real-time beam swapping to accommodate the high mobility networking or sensing scenarios. Fourth, it should allow reconfiguration of beam patterns, communication or sensing algorithms, and network stack. Unfortunately, to date, there is no widely affordable platform which satisfies all the capabilities, which is impeding the research in this field. Other researchers have also developed mmWave platforms based on self-built phase array, such as the OpenMILI project, or purpose-built front-end with discrete components, such as mmFlex or X60. This kind of design is typically expensive, and none of these existing platforms support mmWave MIMO configuration due to the limitations of this RF front-end. The NI mmWave testbed can be used to build up a 2 RF chain MIMO setup with third-party phase arrays, but the cost of over $100 per RF chain limits its adoption. Our MCube platform represents the first mmWave MIMO software radio to overcome these limitations and meet the aforementioned critical requirements. Our main idea is to convert a commodity multi-chain 802.11ad radio to an SDR, so that we can take advantage of the low cost of commercialized antenna array while keeping the flexibility of SDR. Our design will contain a flexible data path. It can use narrowband SDR or wideband ADC or DAC as BPU. Then we designed a real-time control path which provides sub-microsecond latency to support fast beam swapping. We also investigate the phase array module to make the beam pattern reconfigurable. And finally, we designed the massive MIMO architecture with the commodity radio. Please refer to the 20 minutes video and our paper for more details of the design components and evaluations. Putting everything together, this figure illustrates an MCube node with TX and RX breadboards and a 4RX MIMO setup. This MIMO architecture provides unique research opportunities for 5G mmWave networking and sensing. First, our array of phase arrays architecture that the platform can be used for multi-user or single-user MIMO, channel estimation, and MIMO radar. Then, the real-time control for fast beam swapping and data collection give the opportunity to conduct MIMO experiments under high mobility. As a recap, MCube can reproduce the most unique aspects of mmWave radios in a programmable manner. It enables experimental research in mmWave communication and sensing with unprecedented flexibility. Compared with state-of-the-art mmWave platforms, MCube supports larger bandwidth, contains multiple phase arrays for MIMO, and a larger phase array. It can be connected with microwave SDRs and can do fast beam swapping. It also has many times lower cost. To summarize, MQ represents the first mmWave method MIMO software radio. It has been open sourced and can be easily reproduced. We are also distributing MQ replicates to other research groups. Please refer to the project website for more information, and we will also give some demos in the demo session. Thanks for your attention.